In the next few videos, we're going to analyse the transistor version of the iconic Big Muff Pi pedal made by Electro-Harmonix and some versions by Sovtech as well. We're going to specifically look at the transistor versions in these videos and look at the different stages inside and how they process your guitar signal. In a future series, we may also come back and look at the op-amp version of this pedal. But for now, we're going to focus on the transistor version and see how they work. So in a moment, we're going to open up these two and look at the circuits inside. And what we will find is a 4 transistor based series of common emitter amplifiers in a row. Now these are the two that I own. You saw me fix this one in a previous video. And this is my green box bubble font version. And they're very, very similar circuit wise. So let's open them up and have a look. So I have these both open now on the bench, and we should be able to spot some similarities between these two circuits. For example, we know there's 4 common emitter amplifier stages in here, so we're expecting to see 4 transistors, one at the heart of each of those stages. And indeed, we've got 1, 2, 3, 4 in this one, and in this one, 1, 2, 3, 4. I also know there's 2 clipping stages, so I'm expecting to see a bunch of clipping diodes in here. And as we'll see in a moment, there's 2 in each of the 2 clipping stages. So there's actually 4 diodes, and they're here, 1, 2, 3, 4, and here, 1, 2, 3, 4. So although the PCB layout isn't the same, these are similar circuits. You can see, for example, there's an electrolytic capacitor here and one there. And then you've got other capacitors here and here. And then you've got resistors for setting the bias of this circuit around here, and then these all go off to the potentiometers, which are on the other side of the board. So now let's model this circuit in the Falstad application and have a look at what each of these stages do. So I've modeled the entire circuit here in the Falstad Circuit Simulator software, and I'll make this available in the video description for you to play with. And you'll see that it consists of 4 transistor stages, and they're all different configurations of common emitter amplifiers. The most familiar one will be the one on the output because it's very similar to the linear power booster that we've already analysed in previous videos. If we look at the input stage, you'll see there's some differences here, like this 470k and 470 picofarad capacitor feeding back some of the collector back onto the base. And we'll look at what that does when we look at that stage in a future video. Then we've got a sustain control, and that's feeding the signal into 2 identical clipping stages. And we can recognize that these are clipping stages because we can see the diodes here, 1, 2, 3, 4, and we've got some capacitor filters going on here too, and that feedback resistor, but they're exactly the same from this capacitor through to the output, just repeated. And the reason for that is one is soft clipping the signal, as you can see down here from the oscilloscope output, and then this stage is then hard clipping our signal to get that specific sound that we're familiar with. That then gets shaped through a tone stack, and people often take this tone stack and use it in other pedals. And we'll look at how that works as well and what it does to our signal, and some modifications probably that you can do to this if you're designing your own pedal. And then it goes through that familiar output stage, which is basically a linear power booster, just with slightly different values of resistors setting a slightly different bias, because of course our signal's gone through these amplification stages and this tone shaping stage before it's got here, so we have to bias it slightly differently. And then we've got our volume control here, so your sustain control is here, your tone control is here, and your output volume control is here. So what we're going to do is break this down into sections. So the first stage, and then we'll look at the 2 clipping stages together because they're identical other than in operation. Then we'll look at the tone stack, and then we'll look at the output stage, and we'll do an analysis on each of these stages and what they're doing in this transistor version of the pedal. Now, before we continue, it's worth mentioning one of the best guides on this pedal and the circuits, and it was a website developed by Kit Ray, is the bigmuffpage.com, and I'll link these schematic part 1, 2, 3, and 4 below. Some of the links on this website for some reason don't work at the moment, but if you go to each of these parts individually, they do work, and you can just find them if you Google as well. So you'll see if we scan through some of these circuits, starting with the version 1, here's the topology. It's exactly the same, the 4 transistor stages, the clipping diodes, the tone stack, and the output, all based on the common emitter amplifier. And that doesn't change in the transistor versions. What does change is the transistors being used and some of the components around them. And it's interesting what that imparts on the tone, and why some of these versions, such as the Ram's Head and the Triangle, the Red Army version, have become really collectible over the years. Now, if I just jump onto part 3 a minute, which I've got open in a tab up here, and scroll down a little bit, you'll see the Red Army edition, and it uses these KT3102E transistors, and I've actually got a hold of some of these, so as we go through this video series we can build a Red Army version and compare it to the other 2 versions that I've got open on the bench at the moment. So in the meantime, it might be a good idea to familiarize yourself with these different circuit setups and the different versions of this pedal that have come out over the years. There's loads and loads of information here. It's a brilliant resource. So here I have those Russian transistors as used in the Red Army version, and I bought these specifically online so I could make a Big Muff to that specification. Now, you don't need these, of course, to follow along with our experimentation as we go through each stage of this and see how it works. You can use a 5088, as we've been using in the linear power booster, or a 5089. You could use something like a BC548, which has a similar HFE, slightly higher actually in some cases. But don't worry if you don't have one with a high HFE. You could just use a standard 3904 or a 2222. These will still work in the circuit. They may not sound the same as these or be quite as effective, but they will work, and it might be with your particular guitar and your particular pedal chain that you prefer the sound of a certain transistor in your circuit, regardless of its HFE. But most modern transistors, the NPN transistors, will work in this circuit. And indeed, as we've seen from Kit Ray's page, this is part of the tonal difference between some of these versions, the actual selection of transistors in here. So it's definitely something we want to experiment with, as is the components in the tone stack. So we can modify the tone stack to make it slightly differently, or we can stick with one of the tone stacks. And the great thing about this circuit is when we build it in the prototyping stage, we can just swap out transistors and swap out components and create a version of this pedal specifically to our requirements before we then build it into a box, into a final pedal. So over the next few videos, what we're going to do is we're going to go through each of the common emitter stages and the tone stack, and we're going to analyze them properly. We're going to do the DC analysis, some AC analysis, and we're going to look at the thought process that went into designing this pedal and the effect it has on our guitar signal. And we're going to start in the next video with the output stage, and then we're going to look at the tone stack, then we'll look at the input stage, and finally the clipping stages. So that'll be the next few series of videos analysing the transistor version of the Electro-Harmonix and Sovtek Big Muff Pi pedal. In the meantime, have fun looking at Kit Ray's excellent information page, and I'll see you in the next one. I've been Stu from Music Technology. Happy experimenting, and I'll catch you again very soon.